Okay, hello everyone. This week we start to look on the topic malicious softwares, short for malware. And in this week, we will cover some common malwares. And in the beginning, we'll look at the very general kind of concept or definition by some organization for malware. And then we will start with computer virus, computer worms, and Trojan horses, which are the early malwares, like from 1980s to 1990s. And after like 2000 and the development of malwares has been rather rapid, and gradually it's rather complex. So there's kind of no way to introduce a specific example for malware in nowadays, because they are becoming like a toolkit of many malicious softwares altogether, with a set of payload and propagation mechanisms all in one in a toolkit. And it makes the attackers very convenient to carry out rather serious attack against some systems and some organizations. So it's beyond our intention in this course to go very deep about the malwares. But for you to know, it's good to be aware of some of these terms and know its general meanings of some of the malicious softwares we will cover in this week. So let's start with the definition. In general, in fact, there's no widely agreed about what is malware. It's more like a general term that includes all the softwares, programs that has a malicious intention, which could compromise the security attributes like confidentiality, integrity, accountability, or authenticity, or availability of information system. That's a rather general term about malicious software or malicious code. But anyway, when we talk about something, we need like some terms to put people discussion on the same page. You can think of malware like a big umbrella that covers all malicious cyber attacks based on some softwares in the system, in the cyberspace. So it includes computer viruses, computer worms, Trojan horses. As I mentioned, these are the early terms of malwares. And then later on, there are more and more sophisticated malicious software coming into the play. And based on their payload or the harm they perform against the system, then they have some new names like adware, spyware, ransomware, and so on and so forth. If you have read the chapter malware in textbook, in the beginning, the author tries to classify malware. Well, there are many researchers who try to carry out similar work because we want to know better about the malicious software, and we need to follow some way, some path to study of them. And two general classifications that make sense to many people are based on the propagation method or based on the payload of malwares. So then we follow this classification. So we first look at the propagation method. By propagation, it means how the malware spread within a system or within a network from one system to another system. And there are different measures to propagate malicious software. Then we will look at virus, worms, and the other type is the social engineering. There are some other types of spreading as well. And this is about the propagation measures of malware in a system or in a network. There's another type of classification based on what these malwares can do, can harm a computer system that is being attacked. So basically, okay, what are these malicious software can cause against the system? What are the damages could be triggered by malicious software? And based on the damages and the actions, so we can divide malware into different ways based on this payload. So these are the two general classifications of malware. And that's also the reason why you see many terms of malware. Before we start, I would like to draw your attention about some terms of malware. So as you see in the textbook section 6.1, the author gives a short list of common malwares with different terms. And you are supposed to know these terms, and if you are given two different terms, you are supposed to be able to explain what are the differences and what are the notions of those terms. So you need to go through these terms and try to develop your own understanding of these terms. These terms are not necessarily very rigorous as some mathematical definitions. It's based on the characteristics, the damage of some malware, and then some of this definition were formulated. Like adware, it's for the new terms, it's easier to understand its intention. For adware, you can, okay, it's since it starts with add, you can imagine, okay, it's some software that try to lead you to some commercial sites to buy something, or to open up some pop-ups in your system, then allowing you or try to maybe for you to go to buy something. And like for toolkits, rootkits, the rootkit is like a toolkit that covers many different tools, and those of tools are mostly be run with root privilege right. And for like attack cheat. That's another type of term that, in fact, it's in nowadays it's mostly used. It has another term called crimeware. So in the beginning, like before around like the 1980s to 1990s, in these 2 decades, most of these malware are developed by secure like computer geeks or computer experts with rather advanced techniques, and they are quite skilled, so they are able to craft some codes and the implementation to they know many technical details of how computer system works, how a computer system are booted, and how the network works. So they have a rather excellent knowledge and background in the regarding the technical details. So they can find some vulnerability in some designs, and then they implement those computer virus. But later on, as the involvement of computer virus, I see some questions. I will respond to these questions during a break. Yep. And for the since 2000 or 2005, many low-end malwares are connected together, and the key mechanisms about how they spread from one system to another system, and how they damage, how they are able to change the file names or change content of files. All these mechanisms are gathered, and then they are integrated into a toolkit, and which can be sold to adversaries. These adversaries could be an organization, could be an individual. Then it makes cyber attacks more and more seen in the headlines of news, and it increased the population of cyber attacks a lot. I see some questions about the assignment and the book. So for assignments, our teaching assistants are working hard to grade it, but keep in mind, because they are around 250 submissions, and all our TAs, they have also their own studying and working duties, so they cannot have 100% time totally dedicated to grading your assignments. So it takes time. As already mentioned, we hope we can have all the assignments graded in 2 weeks. I see some students already interested in some of the terms, and we will look at these terms one by one. So be patient. So now let's move on to so let's start with a computer virus. I think most of you heard of computer virus from maybe from some video or from some news. Since you are computer science students, you might be interested in this topic and relevant topics. So what is a computer virus? From its general definition, it's a code fragment that attached to another program. or software in a system. So it has a functionality to propagate itself to other programs within a same system or among systems in a network. These two features of virus not necessarily need it to be malicious. In general, the intention of virus is to have some destructive functions against some files, some processes in a system, sometimes even against a whole system. Before we look at the specific examples, let's consider what are the components of a virus and what are the phases of the lifetime of a virus. In fact, for virus, if we look at its definition, it mentions, okay, it hides inside another program and it needs to attach to a program. And it also propagates itself to other programs. It means it needs to infect other programs when it is already attached to a program. And then the last one is this destructive function. So it needs to carry out some destructive functions when it is taking action. So in general, it has 3 parts or 3 components. The first component is, let me see. It's pretty much a real-world virus, like coronavirus or other biological virus. First, it needs to infect a host. And in the context of virus, it needs to infect a host program. So it has this one component, infection component. And the second component of virus is called the triggering or logic bomb. This, the reason of this is because most of virus or most of malwares, they are not necessarily in function all the time. So in general, most of them only take actions during certain time period. So the virus developer or authors, they set up some condition, some logic. When the logic condition is satisfied, then the virus is triggered, is activated. After it's activated, then it will carry out its payload. Basically, it's a functionality, the major functionality, destructive functionality inside the virus. So it has these 3 basic components: infection, triggering or logic bombs, and then this payload, these 3 components. And these 3 components correspond to 3 phases in a virus lifetime. I look at some questions from our students. Well, Tobias asked, are there any example virus without malicious intent? It really depends on how we define what is malicious. And in the early days, the virus, they are not necessary to have malicious functions against the system to destroy a system, to delete some files. And some of the virus in the early days, they are mostly to some computer geeks, as I mentioned. They try to demonstrate their advanced technical competence among peers, among their colleagues, to show, okay, I managed to hack into a system, and I managed to write this virus, and to show some of them, they are more like showing off. It's not necessarily to harm a computer system, but after a while, they feel like some of the developers found, okay, there could be some incentives for them to write the computer virus to destroy some files, like of their enemies, or be hired by some organizations to do malicious function. And I say, let's look at Amy's question. Potentially unwanted program, not. And for when if we talk about whether there are some programs are malicious or not, it's not easy to come to a total agreement about what is malicious, because people could have different perspective, right? And also, but it's important to distinguish virus from computer bugs. That's for most of computer bugs, they are unintentional. So they could be like most of you will be computer software developers. When you develop a rather complex system or a project, then it's rather likely that you may overlook some part, and you might have several bugs in your implementation, which cause some deficiencies of your project, of your program. And this type of it could also disturb or even cause some crash of a system, but it's not that, because it's not intentional. It's kind of by chance or by mistakes. So then we cannot add them into the category of computer virus. Does it make sense to you, Tobias and Emil? Okay, thanks. So let's come back to our the different phases of a virus. Well, it consists of 4 phases. The beginning phases is a dormant phases. Basically, the virus is idle. As I mentioned, most of the malwares are not necessarily carrying out or performing all the time. So they're only a short time period that they are taking action. For the other period, they are idle. So this is the dormant phases of virus, and later on we may mention computer worms that are seen. And the second phase is the propagation or spreading phase. So in this phase, computer virus copies itself into other programs or other areas of the operating system, or even to other computers in the same network. So this is infection phase. And the third phase is a triggering phase. So in this phase, the virus, which has some pre-written logic, and when the logic is met, some of them are based on time, some of them are based on some actions by the victim the victim machine. Like maybe some program is opened, then this virus is activated. Or maybe, okay, the time of the day and the time of the minute matches, then the time of the date and the time of the minute matches, then this virus is activated. And some of them, they directly specify in which time of period the virus can be active. So it varies from virus to virus, but in general, most viruses have this triggering phase to control when the virus is activated and when it will goes into the state of idle. And also here, the last one is okay. I'm coming to this the last phase, execute phase, or this payload phase. And in this phase, a function is performed. So in virus, it's not necessarily just try to spread to infect other computer programs. So it could have its major malicious function or purpose, like to change the name of some files, or change the content of some files, or even delete some content of the file, or overwrite the content of some files. So there could be different purposes in its payload, and that part is execution part. I now also get some questions from students. From Christian, mentioned, would it be best for most viruses to run instantly before they can be removed? That's a good question, Christian. For some of the virus, we will come to that, because virus, it's not just like one side. In most of computer systems, we have two sides. So malware or virus, and the other side is our friend, security experts, and antivirus softwares. And for most of them, the virus need to find some way to hide themselves, to pass the filtering or scanning process of anti-malware softwares. And in some of the cases, some of the virus could want to steal some information, and it may not necessarily, okay, when it infects a computer program, then some information they are targeting is already there. So it's like if you consider some organizations, they have very secret business contract or something like. If an attacker wants to steal this kind of information, some sensitive and secret documents, it's not necessarily the attacker have the full control of when the virus can infect some program. So it's more like a preparation process. And when it's already there, it still maybe need to wait for some special event happens or occurs, or maybe wait for some others. So it's not easy to say like all viruses have the same purposes. Since they have different purposes, so if suppose you are a virus developer, you may need to think of when is the best time that this virus is executed, is taking action in the victim system. I have another question from Tedo. I've heard some security programs have similar properties as malware. Is that true? Security software We will come back to that title. When it comes to from Hackman, when it comes to triggering vs execution, I would compare it between a card triggering. You might work. Yep, that's a good explanation. And one thing that you need to keep in mind that in the early days, most of the viruses, they are specific to different operating system and different platform. So it means like one computer virus, maybe it's designed for Windows, then it's not necessarily be able to run in a Linux system or in Unix-based system. And some of the viruses, they are written specific to specific hardwares. And for some other hardwares, they cannot, within that platform, this virus cannot be run. So it really varies. Let's take a look at of a simple like a fake virus, just to capture the major components of a virus and the face. So you have this, it's a program, and it attached to a host program. So here we have this 3 subroutine. And in the beginning, it has this 1, 2, 7. It's like a marker of this virus, or you can consider it it's like a label of this virus. So this subroutine, it has this infection process to infect executables files in a system. So it has this loop. This loop you see is no, in the beginning, there's no condition whether which kind of the executable it wants to infect. It's quite general. It could be also the one specific virus only wants to infect a process with a specific suffix, like only like VBS, or only affect EXE, or only infect some Python script. So it could vary. And let's see this loop. So here, because it does not specify the format of the suffix of the executables, so it just get a random executable file. And if the first line of this file is 1, 2, 3, 4 till 7, then it go to the loop. This is why it has this marker here. So it means, so when an infected program is run in the system, then the virus will look for randomly, in this case, randomly look for some executables in the computer system. And if that executable already has a 1, 2, 3 till 7, this label for this virus, so then it means this executable has been already infected. So it will go to other, the next executable. That's it's this this 2 lines means. So if not, then prepend V. V is itself the virus to the file. So this is the infection process. In natural language, it's okay. Try to infect some host program. If it's not, if it's already infected, then skip it and look for another victim. If it hasn't infected, then try to infect this host. It's pretty much like a coronavirus or some other virus, right? And then the second part is this payload or part. So this part, so it mentions it can do whatever damage it is to be done. In fact, that is true. In early days, for most of the programs, if the programs can be run, then if the program can modify some files or modify some other programs, since this virus is already attached to that program, so this virus basically has the same access rights or privilege right as the program or as the user who run the program. So you can imagine if the program is run by a root user, so it could be rather dangerous. It could lead to very serious damage to the system because it can access all the files processed in the system. And it can overwrite it, and it can, if we think of how what kind of the functionality one program can have, then basically you can map all the functionalities to a virus. And the third part is this triggering part. So as I mentioned, so, most of the virus, they will have this part, but not necessarily they must have. And so it set up some condition, maybe a set of conditions. And if the condition is satisfied, then the virus is activated. Then you have this, you see, it's a main program. First, infect executable, that's its infection phase. If trigger port, then do damage. So if the condition, the logic bomb is triggered, then exactly the payload of the virus. Otherwise, go to next. And so there's no else in this main program. It means so this virus came to the dormant status or phase. So this is a computer virus. And as you see in this process, if a program in a computer system is infected by a virus, then the size of this infected program will be larger. Although this, you see, it's only a very short pseudocode of a virus, but still, if it's infected, we have this this line, the virus is attached to the file. Then it can be easily detected just based on the size of the program, right? And for virus developers, if they want to hide their virus based on this size, there are several ways, and a very natural way is to compress the virus. Let's see how it works. So this is what I've already mentioned. So suppose here we have this program P1 and this virus, and for each uninfected file P2 here, the virus first try to compress P2 to produce P2 prime, basically to reduce the length of the original program. Sometimes it could try to overwrite some lines of that touched program to make it has the same function as before. And then the virus is attached, either prepend or append to this compressed program P2. And in this case, the resulting program, infected P2 prime, has the same length as the original P2. So this is one natural way to hide a virus in a system. If for some, especially early days, the antivirus software, the first in the beginning scanning the all the files and to save memory, to save storage space, then it only store the size of the files in that system. So that it's a very short this lookup table. You have the program name and then the size of the program. Then for subsequent scanning, then the antivirus software scan all the files in the system and to check whether the size of some programs have been changed or have been increased. If that happens, it means it's a good indicator that the program has been changed. Does it make sense? So this is progress. I already explained. Hageman asked, could you program the virus to search up comments in the program and delete the same amount of bytes as the size of the program? I consider yes, it's doable. There are several ways to not necessarily compress the virus, the attached program. But it also depends on whether the system give access to this modification. There are different ways, but that's a very, very good point, Hageman. You can try to change some lines of a program and then add some short code in it. Alexander mentioned whether it's possible for a program to calculate its method authentication code to see whether it's infected or not. That's a good point, and we will come to that, like how some of these basic infection can be easily detected based on what is so-called signature-based scanning. This signature here it's not necessary to use a method authentication code, but you get the point, and we can calculate its a hash and store the hash in an external device. Then for the next time, if there's any change in one program, then we can the software can detect it. So based on the programs or the files that could be infected by a virus, there are some classification of virus. So here I list these 4 types of virus by the target file. The first one, boot sector infector. For this virus, in fact, that's the very first computer virus, and I will play a video to you. Maybe since it's already 3 o'clock, and maybe it's good to play the video during the break. And then, in fact, this virus, it infects a master boot record. And when the computer system is booted, and in early days, most of the systems they are booted, there's no hard drive of a computer system, and some of them they just use some floppy disk. And then if a system wants to be booted, then the user needs to plug in the floppy disk and then turn the power on, then start the boot, and then to load some very simple basic document OS system, this DOS system. And we will see this virus called Brain, and it's a name of a brother, of 2 brothers about this boot sector infector. Another type of virus is directly infect some files. Later on, it comes to this macro virus. which infects a file with macro or scripting language codes that can be interpreted by some applications. And it's mostly for Word documents and Excel documents, and also for PDF documents. And the last type, what is called multi-party virus. So it's more advanced than the beginning we mentioned. It's a simple virus. So it can infect files in multiple ways. We can have a 15-minute break, and during the break, I will play the video that introduce the brain virus. It's a quite interesting video. It was made by Finnish security experts, who is also a fantastic speaker. So, okay, let's continue our lecture about the computer virus. And we have mentioned the types of virus, and let's look at how virus propagate among programs. I already explained this in some of the slides before, but now let's take a closer look at it. So in general, it randomly selects some executable files, but not necessarily just the exe. It could be VBS, like the Visual Basic Script, or some other executable files in the system, and then insert itself to the target if it is allowed to. And that's come to the, okay, if there's some access control mechanism in the system, then this type of infection could be avoided, could be prevented. Another way is it can reside in memory and attach itself to the target when an external drive is inserted to the computer. That's what I described, like if you have a floppy disk or if you are USB stick, then you insert in a machine. If the machine is infected, then this floppy disk or this USB stick could be infected, very likely. Another one is spread through infected softwares that appear to be useful and free software publicly available. I would say that's a rather common way to get a computer infected. And I think all people like free lunch. So, and also in many countries, this copyright thing is not properly protected in the early stage. During break, I mentioned I used in college life, I used some of the softwares that are free. And when you are used to use free softwares, and if you need some software that with good functionalities, then it's a rather natural, it's a tendency that people will search around in the internet for free software. And this is a very common way to get a clean computer infected with virus. Another propagation measure is an email attachment. Like if you receive some email with the attachment of some software or some flash, this flash code or some other very short code, script code, then in this case, if you click it and run it, then your computer, your machine could be infected. And the last one is this macro virus. In fact, this after around 10 years, the macro virus is the most prevalent virus in the internet. There are several reasons of it. Let me see whether I have this. Okay, not yet. In fact, the reason microvirus is more serious is because first, in many computer systems, this microvirus is attached to or embedded in a document instead of a progress, instead of an application. So, like in Windows Office, like the doc, the Word documents, Excel documents, they have this functionality of this macro scripting. And its original purpose is to automate some process to save the time of users' keystroke, to make it some tedious task more automated. That's the original purpose of macro. And because of this original purpose, most people would activate this functionality in the world. And also it's embedded in this, it's also included in Excel. And in PDF documents, in the beginning, they also have this functionality. They can run some JavaScript. I know you haven't learned JavaScript yet, but it's basically some script code, like your Python code, and it has some functionality. So it's a part of this basic programming. And these files, when it is opened, then it's very likely that the user will allow this macro script or macro code to run, because mostly users don't really know what are these macro function words before they run it, right? You can only get this, nowadays you have this kind of warning message from the Microsoft Office mentioned it could be dangerous to run this macro. Are you sure you want to allow this macro code? But in the early days, there's no such warning message at all. And because I would say like the operating system learned from brain or from the early computer virus, they know, okay, computer virus infected the programs, the executable files, then there should be more tight access control policies on these programs. Which of the users, which of the programs can run other programs, can modify other programs. And that's like after like several years lessons, then they have this more strict access control policies in many operating systems. But they don't really have specific access control policy on files, on documents. Because that's, in general, these documents, they have the nature of being shared among others. Like you have some report and in the Excel, and then you share with your collaborator, you share with your colleague, you share with your fellow students. That's normal. That's how the files are supposed to be. Right? That's part of its nature. That it makes the access policy rather difficult to detect it or to restrict some of this macro or code or scripting code to be run in a system. And that's the kind of major reason of this macro virus. It caused more serious problems than other computer virus. Before we move on to computer worms, and there's also some classification about virus based on their concealment strategy. This, as I mentioned, it's like a war of two sides, virus developers and security experts or antivirus software developers. So virus developers want to hide their virus, want to keep their virus stay longer in a computer system. And antivirus software developers want to find existing virus or some new virus based on their signature, based on their behavior. So it's a kind of a racing of arms. And there are some ways that viruses try to hide themselves in a computer system. And the first way is what is called encrypted virus. Well, in this virus, it has a portion that creates a random encryption key. And this key is used to encrypt the remainder of the virus. And for when it is invoked, this encryption key is also stored as a part of the virus. And when the virus is invoked, then the key is used to decrypt the payload of the virus, and then the virus can be running and causing some destructive functions or destructive damages in a system. And in most of these encrypted virus, the key is changed every time. So that's why each time they choose a random encryption key. So it means that the ciphertext of the payload of a virus, it varies from time to time. And previously, we already mentioned, okay, to detect a virus based on its size, or even based on the signature, the hash of the virus. But this encrypted virus, you can see it's very difficult to detect because each time it has different ciphertext. And you cannot have this signature stored in the antivirus software. So this is the first category. The second one is a stealth virus. In this way, it's kind of a more general term. It can be seen as the general term of the other three. So the basic idea is explicitly designed to hide the virus from being detected by antivirus software. And the third one is a polymorphic virus. In this type of virus, each time it will mutate, it will change some lines of its content of its payload, such that it has the essentially equivalent functions as the previous one. So in this case, each time if some antivirus software wants to detect it based on signature, then it's very difficult to detect this type of virus, because each time it changes some part of its content. The last type of virus is called the metamorphic virus. And this type of virus rewrites themselves each time at each iteration. Or sometimes it even changes behavior as well as its appearance. Or it's kind of quite advanced virus. I suppose it's widely used in included in many attack kits. So these are the rather general introduction of virus. We mentioned its components, its phases of its lifetime, and how it can affect the propagation measures and also the concealment strategy of different viruses. Next, there are many examples, and we have played the video about the brain virus. After that, there are many viruses. Here, this Melissa, maybe it's not accurate to keep Melissa here because it has the features of virus, computer worms, and the Trojan horse. So in some sense, it's not easy to just put Melissa into either virus or worms. But the reason we have it here because it's this macro virus. And let's take like it's Melissa. We have file here. We have the C code and also the real code. Let's take a quick look at how it works. This microvirus here in the textbook, you have the macrovirus pseudocode, and I will share with you this the original code of Melissa. You see, it's a Melissa virus source code. And in this pseudocode, the first step of this code is the name is document open. So when it open the Word document, first it's disable macro menu and some macro security features. This is I would say it's a clever and nasty. So when the user or the victim open up this piece of code, it's first it will disable the security features of the attached Word document. And then even the user realize, okay, this is a worm or this is a malicious code, and he cannot or he or she cannot stop it. So there's very little the victim can do with this code because it's especially this payload, it sent out the itself to other contacts in its address book. So then let's look at the second step of Melissa. If it's called from a user document, then it copies macro code into normal template file. If you are familiar with a Word document, then you would be able to get the seriality of this normal template file. Because whenever you open a document file, by default, it uses normal template file. For many more advanced Word users, they may customize this normal template file for their use. So basically, it's by default to be used in all the Word documents. And here, like else, okay, if it's not opened by this user document, then copy this macro code into user document being open. So it means if when it is wrong, then if there's some document is opened in the system, then it tries to copy itself, this macro code, to all the documents being opened. And then it has it modifies some registration files in Windows. As if the registry key Melissa not present, then and if Outlook is email client, and the target of Melissa is Windows systems. So for many Windows systems at that time, they by default they use Outlook, this email client. So here, if the victim system has no Melissa in the registration key, this keyword in its Windows system files, it means this system is clean. And it looks for whether the system use Outlook as its email client. If they use, then it send the email to the first 50 addresses in its address book with the currently infected document attached by basically this Melissa macro code. And it's embedded in a document, in fact. And after that, then create this registration key, Melissa. It's pretty much like how computer virus infect a new computer program. So if there's low label of the virus in that program, then infect this program. After that, to save time, then it add this label of the virus here, because it's more like itself. It's a worm, so it is a standalone alone program. So its target is a host machine, host system, not a host program. So this itself, so it leaves this registration key, this Melissa, basically name or label of it, in the system, means this system has been infected. And here is the triggering condition. If minute in hour equals day of month, then insert text into document being opened. As I mentioned, it's not necessary to have the worm or the computer virus running all the time. For Melissa, if the minute in hour equals the day of the month, then it runs. After that, everything is normal. User do not really realize there's something wrong. Because if it's all running all the time, either the user will experience some downgrade of the performance of the system, or maybe it already caused some serious problem. But here, this Melissa, it takes action in a more hidden way. So that's also why it's rather serious than previous computer virus. So it is regarded as the first kind of proof of concept of computer worms. Okay, let me see. Christian asked a question. Doesn't the label make it easier to identify all infected files when the first file is discovered? It's a balance. It's a trade-off. Yes or no. For some of the antivirus softwares, they do not scan all the content in a program. They may scan the metadata about the program, about the files, not necessarily whole content, because it takes time. But for many users, if they run the antivirus software and it has this complete or comprehensive scan of the system, then it might mean that this process may take more than 10 hours to scan all the files, all the contents in the system. And some of these antivirus software, they provide this called quick scan function. Then for this, they might this function, they might only touch the a subset of progresses or a subset of programs or files in a system, or they may only look at some metadata of the file to check, okay, when the file is updated, when the file is modified, what's the size, and compare to the information stored from the last scanning. So it's like a paradox or trade-off for the virus or worms developer. The reason is like to have better or more faster spread rate than if a computer system already infected before. Then for this payload part, it's a kind of a waste of time in terms of spreading speed, because the first 50 address was already received the worms before. So in this case, it's kind of does not increase the spread of the worm. That's my understanding of why they add this label to in the computer system. I'm not sure whether it makes sense to you. So this here, the part that I labeled with a red square, it matches this CDO code. And for the other part, we can skip, but you can see like here for this address book, then they send the file itself, this recipients, and then if X larger than 50, then it stops. And also the subject is important message from the victim computer. And the body is here's that document you asked for. Don't show anyone else. I remember I have some information. Let me see whether I can find the screenshot of Melissa. Okay, it's here. So this when the receiver received the email, the subject, okay, important message from from your colleague or from your teacher, from your boss, then here's a document you asked for. Don't show anyone else. Then it's kind of psychologically motivates the people to click on it, and even they made some mistake, and they are not willing to tell others. In fact, what I described as Melissa, it's itself, I would treat it as a computer worm. Let's look at the general definition of a computer worm. First, it's different from computer virus. It can run independently. So the worm itself is a standalone program. It's not like a virus. It has to attach to other program. And regarding propagation, or like what is so-called self-replicate, it's pretty much the same. So it propagates a complete working version of the self onto other hosts on a network. So previously, computer virus, it's also in 1980s, they are not connected, most of the computer systems. So they can only, in most cases, affected the other programs, other softwares in the same computer. But in 1990s, since the invention of the internet, many computers, more and more computers are connected. So it's natural, I mean, from the perspective of malware developers, that why we only need to only restrict ourselves to propagate within a computer, within a victim machine. It will be better to spread around the world through the internet, through the internet cable, right? So then they have this idea of propagate the softwares with these malicious functions in the network. And regarding payload of worms, there's no essential difference from computer virus because it's just a computer program. And if it is running, and if it has sufficient privilege rights in a system, then it can do all the things that the system allows this program to do. It could be rather destructive. And these are the there's some of these worms to like a general introduction of these worms. I can skip it and you can read it. For regarding propagation, there are some ways that are a bit different from computer virus. So this here, it's also listed in the textbook, the 5 ways that worm replicate itself or propagate to other computers. First, by emails or instant message. And the second, by file sharing, because some of these worms, they can be very short script code, and it can be embedded into some documents. Then it's quite natural to spread within file sharing protocols or mechanisms. And also, in some cases, it can enable what is so-called remote execution capability or remote file access capability. When the computer is infected by some worms, if this worm has some privilege right, and it might be able to open some connection to connected computers. And in this case, one thing is the worm will try to send itself to the connected computer to get that computer infected as well. And also, it could use some vulnerability of the system configuration or some software which give this computer some access to the system. Then basically that connected computer opens the door to this worm by some misconfiguration or by some vulnerability of a system. And the last one is remote logging capability. So the worm could be able to log on to the remote system as a user. then use the command to copy the self from one system to other. This is also like if the system got infected and the worm tries to log in like a SSH or previously this telnet, this command to a server. And if the user use the same password for different systems, and if by some chance the user password can be corrected by in some other ways by this worm, then the worm will use the same credential, or at least try the same credential to log into other computer system to propagate, to send the file to the other system. These are some general ways that a worm can replicate itself. There are also rather a lot of infamous worms that has caused many problems. Sometimes it's only like disturbing, allowing problems. Some of them cause rather destructive problems. I have downloaded several of these demos, and I only, due to the time limit, I will only play the first one, this Happy 99.9. Let me see whether I can see it. Okay. This is again a Windows worm, and it's not necessarily cause any malicious harm to the victim system, but in fact, it tries to greet you for the 2000. This let me see whether I can find it. Oops, sorry about it. When you open it, you say very nice for 5 words.
Start time, duration, and repeats.
This song will automatically happen on the system.
The user has to go to this Windows manager and then close it by force. That's a type of worm. It's a Happy 99. And again, it's an email worm. Like if a user so birthday is approaching, then received some greeting message from a friend or from a old colleague, then it's very likely this user will open such an email attachment. Here's the greeting card I prepared for you. I wish you all the best for your birthday. Then with quite attractive appearance. And in most of cases, users will open it. There are some other worms, this I love you, and you can search for it and there are many demos and video about these examples at YouTube. I think we can stop here. And sorry about this few minute delay.